Lewis structure. Objective. After reviewing this video, you will be able to define Lewis structure, create a Lewis structure when given an element, define and identify the number of valence electrons when given the element.
VOCABULARY. Vocabulary.
Valence electrons. The number of electrons in the outermost principal energy level. So for example, if we have 3 protons, in the first ring we will have 2 electrons, and in the last ring we will have the remaining third electron. So we have 1 valence electron. Lewis structures, also known as electron dot diagrams. They show the valence electrons. Later in the video we will go over specifically how to create a Lewis structure. Did you know there are certain compounds that have more than one way to draw the Lewis structure? These abnormalities are called resonance structures. And so the only difference is they're drawn one way on one side, on the left side. Over here it's drawn one way. However, the second way that we could draw it is over here on the right side. And if you want to spend a lot of time going over some organic chemistry and how to do all this stuff, we could, but we'll save it for a later day. Creating Lewis structures. So first one, I'm just going to do an example, and then I'm going to go over how to do it. So you need 2 things. You need an element, and you need to write the valence electrons. So the first element that we're going to use is fluorine. Okay. The valence electrons, well, if you look in the periodic table, fluorine is in group 17, so it should have 7 valence electrons. And so the electrons will be represented with dots in this case. So if you count, we have 1, 2, 3, 4, 5, 6, 7. 7 valence electrons. Creating a Lewis structure. So now let's actually go over this. So you need 2 things, an element and a valence electrons. So the element that we're going to use in this case will be element X. So now let's draw the valence electrons. When we do that, we need to create the s orbital. So this is going back to orbitals. If you need to review that video, you should go back and watch it. But the s orbital can hold how many electrons? That's right, 2. So we need to represent those with 2 dots for our 2 electrons. Then after the s orbital came the p orbital. Okay, so we need to put 1 in one of the p orbitals, another one in the second one, and another electron in the third one. Remember, we had to fill in each one first before we could fill in 2. So after we put 1 in each, now I'm filling them in with a second one, and now I will have a full complete outer shell, which my S and P, if you add those up, 2 plus 6 would be 8. So now let's actually create a Lewis structure. So let's go over step by step. So let's do this for the element sulfur. So the first thing we need to do is write down our element symbol, which for sulfur is the letter S. Good. Next thing, we need to determine the number of valence electrons sulfur has. Well, if we look on the periodic table, sulfur is in group 16, and so it should have 6 valence electrons. And again, remember, everything in group 16, all elements in group 16 will have 6 valence electrons. Now we need to fill in the s orbitals, and so we need to put our 2 electrons there, so 2 on the top. Next, we need to fill in our different p orbitals, and again, we need to put 1 electron in each orbital first before we can fill them in, just like our orbital diagrams. So 1, 2, 3, and now we can start filling in 2. So right now we have 5, and now we just need to add 1 more, and we'll have 6 valence electrons to represent sulfur. Lewis structure for ions. For potassium, K+, because it is in group 1, it has one valence electron, and it's going to want to lose that one valence electron. And so when we remove that electron, we will put the K with the brackets and a plus symbol. Again, it lost all its valence electrons. Now, let's try one when we gain electrons. And so we'll do this for oxygen. And oxygen becomes a 2- because it's in group 16, and it's going to want to gain 2 electrons to look like the noble gas. And so oxygen here, we'll put our 2 electrons in our S, and then we'll put 1 in each one for our P before we fill them in. So here's oxygen right now, but we gain 2 electrons, and so we need to add 1, 2. And so now we have 8 electrons in the outer shell, and we represent this being an ion with brackets and then a 2- on the outside. So again, it has a full outer shell because oxygen has gained 2 electrons.